let's look at improper integrals now. I want you to determine whether the integral is convergent or divergent. So we're going to do two of these. So part A, the integral will be the integral from 1 to infinity, 1 over 2x plus 1 cubed dx. Now this is obviously going to be an improper integral because of the infinity right there. Your first step with improper integrals is always to put in a limit. I cannot compute the integral until I get rid of that infinity. And now that that infinity is gone, I can compute this integral. So we're going to use substitution here. U would be 2x plus 1. Du would be 2 dx. So I'm getting the limit as t goes to infinity. It should be 1/2. And you'll get 1 over u cubed. And then remember we have to change our bounds. Here, if x is 1, then u will be 3. And if x is t, u will be 2t plus 1. So now we do our reverse power rule here. The limit as t goes to infinity, 1/2 u to the -2 over -2. And then plug in top minus bottom. You'll get a -1/4, 2t plus 1 squared. It'll be minus a negative, so plus 1 over 4 times 3 squared. And now we've got to compute this limit. So look at this first term here. The numerator is constant, it's always -1, and the denominator is going to go to infinity. So this limit is going to be 0 plus 1 over 36. So this limit converged, which means that the integral converges. Okay. Let's look at another one of these. So B, the integral we're going to look at is 0 to 1, 1 over x dx. Now, this isn't obviously an improper integral, but I will say that this is an improper integral. Why is it an improper integral? This function right here is undefined when x equals 0. So I've got to put in a limit, and because this is a fixed number here, you're going to have a one-sided limit. It'll be as t approaches 0 from the right. And now because I got rid of that 0 by putting in a limit, I can now compute this integral. It would be ln of x. And then top number minus bottom number, ln of 1 minus ln of t. ln of 1 is just going to be 0. And then if I look, what happens to ln as t goes to 0 from the right, this will go to negative infinity, but there's a negative here, so this limit will be infinity. So this integral, the limit diverged, so the integral diverges. So I'll say the integral diverges. So now I want to spend a little bit of time talking about series. And the first thing we're going to talk about is a geometric series. Remember, there are conditions on a geometric series. It depends on R, so it converges if the absolute value of R is less than 1. And in that case, the sum is A over 1 minus R. And it diverges if the absolute value of R is greater than or equal to 1. So let's look at an example of a geometric series. Let's say for this series, I want to know, does the series converge or diverge? And if it converges, find the sum. So we're going to rewrite our series here. This is the same 8 over 2 to the n. I can rewrite this as 8 times 1/2 to the n. And hopefully from here you can identify what our R is 1/2. The absolute value of R is less than 1. So this series converges. And to find our sum, we need to know R and we need to know A. So A is the first term in our series. It's 8, plug in n equals 3. That's the first term in our series. So A will be 1. And then the sum is A over 1 minus R. So the sum would be 2. We're going to look at one final series problem, telescoping series. Let's look at the following example. Let's find the sum of the series. N equals 1 to infinity, 1 over n plus 1. So remember that this kind of reminds you of what we did back with partial fractions. If I swap out the n for x's, the denominator is already factored, and so I can use my partial fraction decomposition and solve for a and b much like we did before. Ax plus 1 plus bx, plug in values for x. If x is 0, you're going to get that a is 1. And if x is negative 1, we'll see that b is going to be negative 1. And so then my series is going to become, it's the same thing as 1 over n, swap back out the x for n, minus 1 over n plus 1. And now we're going to start writing out our partial sum. So S1 would be 1 minus 1/2. S2 would be 1 minus 1/2 plus 1/2 minus 1/3. And if you notice, the two 1/2s will cancel, negative and positive. S3, 1 minus 1/2 plus 1/2 minus 1/3 plus 1/3 minus 1/4. So the two 1/2s cancel, negative 1/3, positive 1/3 cancel. Hopefully now you can kind of see a pattern and write a formula for Sn. Sn, 1 minus 1 over n plus 1. And then we take the limit of our partial sums. The limit of 1 minus 1 over n plus 1. That limit is going to be 1. So I can say that this series converges, and the sum is 1.